Hello viewers on YouTube. In this video tutorial, we are going to consider a basic introduction to complex number. Your first question might be, what exactly is a complex number? In order to understand what a complex number is in essence, let's consider an equation in the form x squared plus 4 equals 0. If you are meant to solve this equation, the first thing we'll consider doing is to either subtract 4 from both sides, or in other words, take 4 to the side. Therefore, x squared would be equals to negative 4. And the next step is to take the square root of both sides. So the root of x squared becomes plus or minus the root of negative 4. Square cancels root. At left side, we're left with x. And at the right side, we have plus or minus square root of 4. Since we learned algebra, we know that square root of negative 4 can be expressed as x to be equals to plus or minus the root of 4 times negative 1. And in fact, the root can be distributed. And we have x to be equals to plus or minus the root of 4 times the root of negative 1. Now, earlier at this point, in our general math, we would have said that this is our final answer as we can't move forward anymore. But now, we are still few steps away. The reason why we are doing this is all because we are trying to simplify this to the least form. And to end up with the least form, we need to introduce the complex number. At this point, the square root of negative 1, we want to represent it with letter I, as the root of 4 can be gotten easily, but the root of negative 4 is impossible. So for we to simplify the root of negative values, that is why complex number is introduced. So therefore, we now have x to be equals to plus or minus, the root of 4 is 2, and we said the root of negative 1 is I. Keep in mind, it must be 1. The root of negative 1 is I, where I squared will now becomes negative 1. Perfect. So I is complex number, while this 2 is called imaginary number. The value attached to the complex number, or attached to I, is the one we called the imaginary number. Perfect. Now, sometimes complex number might not just be in this form, whereby you have imaginary number to be attached to the complex symbol or to the complex number. Sometimes it might include real numbers. And what form is this? When complex number z is usually the way or the form we use to represent complex number, if z is equal to a plus bi, then in this case we said z is represented in a rectangular complex number, or is a rectangular complex number. It's a complex number that includes real parts and imaginary parts. Take for instance, if z is a complex number and it's equals to 3 plus 2i, z is not just a complex number, it's a rectangular complex number. It is x here that is just a complex number because it has imaginary number and the square root of I. But this z has the real parts, so therefore it's a special case of complex number called rectangular complex number. So we are required to identify the real part of z, which is written for short as Re of z. The result is 3. You take this part. You can see that 3 standing alone is like a real number. Perfect. Now for this 2i, you can see they are complex number. So we will be required to find the imaginary part. And it's written for short as Im of z. And the result is 2. If this was minus, or if this is minus, then it will be minus 2. So that's how to easily identify the real parts and the imaginary part of a complex number. Perfect. Now, to put it into practice, let's consider a standard quadratic equation. I hope you now know how the complex number is introduced and how it is used. So consider this equation, x squared minus 2x plus 5 equals 0. This quadratic equation is infactorizable. You can't solve it using factorization method. And here is the reason why. You can never get two numbers that will multiply to 5 and at the end of the day, we add up to -2. This is absolutely impossible. So to solve this equation, we can either use two methods. That of the completing the square or the quadratic formula, also called the almighty formula. So in this video, we will consider using the almighty formula. We need the value of a, which is the coefficient of x squared, which is in this case equals to 1. The value of b, which is the coefficient of x, which is -2, and the value of c, which is the constant, +5. So what says the formula? It says that the value of the variable will be equals to -b plus or minus the square root of b squared minus 4ac, all divided by 2a. Upon substitution, we have negative times -2 plus or minus the square root of -2 squared minus 4 times a, that's 1, times c, that's 5, all divided by 2a, that's 2 times 1. Simplifying forward, we have minus times -2 is 2, plus or minus the square root. -2 squared is 4, minus 4 times 1 times 5 is 20. Then eventually, we have division of 2. So x is what is still equal to them. Simplifying more forward, we now have the value of x to be equals to 2 plus or minus the square root. 4 minus 20 gives us -16, divided by 2. In a normal circumstance, in algebra, we can say this is our final answer. But now that we have introduced complex number, we can simplify this more forward. So instead of square root of -16, let's split it. This is the same as saying x equals to 2 plus or minus the square root of 16 times -1, all divided by 2. And upon distributing the square root to 16 and -1, we now have x to be equals to 2 plus or minus the root of 16 times the root of -1. We still have division of 2, and x becomes 2 plus or minus the root of 16 is 4, and we said the root of -1 is I. Everything divided by 2. In fact, this is still not our final answer, as we can still simplify more forward. So the complex number helps us to simplify quadratic equation to the least form, more especially because the ones that are infactorizing, or the one that has complex roots. So therefore, we have x to be equals to, so let's distribute the sign, 2 plus 4i over 2 and 2 minus 4i over 2. So those are the values of x. So x can be this and that. It should be this or this. Let me use or instead. Okay, perfect. So now upon factorizing 2 outside at the numerator, we have x to be equal to 2 in the bracket of 1 plus 2i, all divided by 2, or 2 in the bracket of 1 minus 2i, all divided by 2. And since the 2 can reduce this, left over for the value of x is 1 plus 2i, or 1 minus 2i. So these are the values of x. And if, for instance, when x is equal to 1 plus 2i, we have to identify the real part of x and the imaginary part of x. Then for the real part, we would have had 1, and for the imaginary part, we would have 2. And when x is 1 minus 2i, the real part will still be 1, but the imaginary will change in this case and becomes -2. So that's how to simplify quadratic equations that are infactorizable to the least form and identify the real parts and that of the imaginary parts. So this is a basic introduction to complex number. As we move forward in our subsequent videos, we will be talking about the algebraic or the algebra of complex numbers. I hope you find this helpful and understandable. Thanks for watching. See you in the next video. Bye for now. Feel free to subscribe if you are yet to do so. Also, you can leave a like. Thank you. Bye for now. So this is your exercise. Feel free to share a solution if you are in the comment section below. So you solve this quadratic equation to the least form and tell me the value of x. Okay, 12. Thank you once again. Bye for now.